Alright, so today we're going to be talking about slope-intercept form and how it relates to graphs. So we're going to be having an equation and we're going to graph the equation, or we're going to have a graph and we're going to turn it into the slope-intercept form equation. So here we go. So this time we have a graph, we need to write it in slope-intercept form, we need the equation. So we know that we're definitely going to need y equals something, x, and then plus or minus the y-intercept. So the first thing we need to find, the easiest thing, is going to be the y-intercept, and that is always where it crosses the y-axis. Remember that this is the y-axis, this is the x-axis, so we need this axis right here. Well, this is where it crosses the y-axis, and that is positive 1. Here's 0, so it crosses at positive 1. So I can say my y-intercept is plus 1, positive 1. So I found my intercept, now I need my slope. Well, remember that slope is change in y over change in x, or divided by change in x. So I need perfect points. So here's a perfect point. My y-intercept in this case is a perfect point. Here's a perfect point, and by perfect point I mean where the graph crosses, and it crosses at an integer like 1, 2, 3, 4, not at a decimal or a fraction. So like this is not a perfect point. That's not a perfect point. That's close, but that's not a perfect point. We need perfect points. Here's another perfect point, and there's another one. So in this case we have 4 perfect points that we can see on the graph. So we need our change in y, which is up and down, divided by our change in x, which is left and right. So our change in y is up 1. Remember, we're going from left to right. So increasing by 1 over 1. Also increasing. Up is positive. Think of like a thermometer. The numbers that go up, we're going in a positive direction. The numbers that go down are negatives. And then for the x-axis, think just the normal number line. If it's to the right of 0, it's positive. To the left is negative. If we're moving toward the positive numbers, that's a positive direction. So again, we're going up, increasing by 1, to the right 1. Up 1, over, to the right 1. So my slope then is 1 over positive 1. So positive 1 divided by positive 1, which is just 1. So y equals 1x plus 1, or just y equals x plus 1. Simple as that. Alright, next graph. So remember, the first thing I want is my y-intercept. So y equals. Here is my y-intercept. This is where it crosses the y-axis. Well, that looks like it's at 0. Looks like a perfect point at 0. So I can write plus 0. Now my slope, again, I need perfect points. So here's 1, here's 1. In this case I'm going down, which is negative 1, over to the right, which is 1, down, which is negative 1, to the right, which is positive 1. So my slope is negative 1 over positive 1x. Now, negative 1 divided by positive 1. Well, a negative divided by a positive is a negative. So y equals negative 1x plus 0. I can write that, but I don't have to. A lot of times if you have a multiple choice, you're probably not going to have plus 0 as an answer. It's just going to be not there. So what I have now is negative 1x, negative 1 times x. You probably won't see that either in a multiple choice. What you will probably see is y equals negative x, because negative x is the same thing as negative 1 times x. 1 is like it's like a ninja coefficient. It's there, but it doesn't have to be there. If it's not there, you assume that it's a 1. So technically this is still a negative 1x. And finally, we have this. So again, we need y equals my y-intercept. In this case, if this is 0 and that's 1, that looks like it's directly in the middle, so plus 1/2. It's positive because it's above 0. Plus 1/2, or 0.5, plus 0.5. My slope, so perfect point. Well, I don't really have any perfect points, so I'm going to have to work with what they give me. I'm increasing, I'm going up. Well, I'm not going up at all, am I? It's just straight. It's a straight line. If this was a patient in the hospital on the heart machine, they would be dead. There's 0 pulse, right? It's not going up. 0. So it's increasing by 0. So 0, my change in y, divided by my change in x. Well, that's a plus 1, plus 1. 0 over 1x. You put that in your calculator, 0 divided by 1, it's just 0. So y equals 0x plus 0.5. Well, anything times 0 is 0. So again, if you have a multiple choice, there's not going to be an answer that says 0x, most likely. So what you're going to do is, since anything times 0 is 0, and 0 means nothing's there, you can just go like this. Y equals 0.5. And that's it. Y equals 0.5 or y equals 1/2. So there's 3 examples of taking a graph and turning it into an equation. So now we're going to have an equation, we're going to graph it. Okay? So remember, when we had the graph turning it into an equation, the first thing we started with was the y-intercept because it's the easiest thing to find. Well, in this case, that's going to be the easiest thing to graph. -3 minus 3, that's my y-intercept. So here's 0. Remember, this is the y-axis, this is the x-axis. So I'm going to go 3 below 0. -1, -2, -3. I'm going to put a point right there. So my first point is going to be my y-intercept. Now, my slope. Well, this is my slope. Okay? Remember, it's rise over run, but I don't see a bottom number. Well, guess what? I can add in a bottom number as long as it's 1. Because anything divided by 1 doesn't change. That's the identity property of multiplication, or in this case, division. 2 divided by 1 is still 2. So I can turn that into a fraction by just putting it over 1. So my rise is 2. My change in y over my change in x. My change in y, my rise is 2. My change in x, my run, is positive 1. So I started with my y-intercept. From there, I'm going to go up 1, 2 over 1. I'm going to put a point. I'm going to go up 1, 2 over 1. And I can keep going. 1, up 2 over 1. And if I keep going, it's going to make a line. That's what I need. I need it to make a line. So my y-intercept is -3. My slope is positive 2. Now that's not the best line in the world. That's because I'm using my hand and my eyeballs to draw it, and those aren't perfect things. If I had a ruler, it would look a lot better. Okay, so now we have a fraction, but don't freak out. Fractions are actually useful when we're graphing equations. So my change in y looks like divided by change in x. So my change in y is a -1. That means I'm going down. My change in x is a positive 3. So -1 over positive 3. Alright. So here's my graph. Now my y-intercept is positive 2. That's where I'm going to start. And then my change in y was -1. So I'm going to go down 1. My change in x is positive 3. So 1, 2, 3. And I need to do it one more time. You really need 3 points to make a good line, because if you do the first point, or the second point in this case, if you do that wrong and you don't do a third point, you're not going to know. But if you do 3 points, you'll know if something's fishy because they won't be in the same line. So I went down 1 over 3. I'm going to go down 1 over 3 again. 1, 2, 3. And now I have enough points to make a good line. And again, I'm drawing this by hand, so it's not perfectly straight, but you get the picture. Okay, last one, y equals -2. Okay, now the first thing I'm going to do is my y-intercept. Remember, y-intercept is the constant. It doesn't have an x attached to it. In fact, it doesn't have anything attached to it. So my y-intercept in this case is -2. So here's 0. I go down 1, 2. There is my y-intercept. My slope, well, there is no x. Technically, I can rewrite this as y equals 0x minus 2. And it's still the same thing as y equals -2, because 0 times anything is 0, and 0 minus or plus anything doesn't change it. So you don't have to do anything there. You just know that the slope is 0. So I rise 0 and I run 1. Technically it's 0 over 1. Remember, I can turn that into a fraction by just putting it over 1. So I rise 0, I run 1, I rise 0, and I run 1. So there's my 3 points for making a good line. And remember, that's a horizontal line. Horizontal, 0 slope, y equals -2 is the equation in this case. Alright, so that's it. Now we're going to practice as a class.